Hello everyone, this is our B project and we are students from Artificial Intelligence and Data Science Department from Vivekananda Education Society's Institute of Technology. We are creating this project under the mentorship of Dr. Anjali Yevle, and the title of our project is Lawgarithm. It's a one-stop solution for all your legal queries and assistance. My team members are Alok Kale, Shri Prasad Navre, Khalid Sayyed and Soham Shetty. So first of all, let me take you over the problem statement. So navigating the complexities of the Indian law to identify applicable charges for specific legal actions is a time-consuming and intricate task. After requiring deep legal expertise, these challenges faced not only by legal professionals but also by individuals seeking to understand their legal standing. So as you guys already know what our problem statement is, let me take you over to the solution we have proposed. So we plan to fine tune an already built large language model from a very big firm, like we are using Llama here, and we plan to fine tune it on our specific data set, and here we are targeting specifically Indian law queries and all the disputes related to Indian land laws. So in this process, the first step which we require, like any other artificial intelligence project, is the data set. So here first of all, a very major issue with data sets is, in such type of project, is the authenticity of the data set. So and there is a very shortage of the data which we are planning to get. So here we have planned to create our own data set using the RAG, and we are using the model of Google Flat Excel. So for performing RAG, the data which we are using to scrape and make the vector database, we are using authentic books written by our own Indian constitution, so that there is no way we get unauthentic data. Also, we are using FAISS for our vector database. This way we are creating our own data set using RAG. This data set is very authentic, and we are getting a very huge request for our data set. As we know that our data set is ready, now we move to the fine tuning part. So for fine tuning, first of all, we have tried multiple ways of fine tuning it. So the most basic way of fine tuning an LLM is through transfer learning, but as everyone knows, it's a very resource expensive method. So next we have tried to do it using LoRa, and the best way to do it is using the base model from Unsloth library. Unsloth is a library brought to us using PyTorch, and it really speeds up all the fine-tuning processes. Especially in the base model, we can get up to 4 times faster fine-tuning methods. As I have already gone through the process which we are planning to do the fine-tuning and make our project, let me take you through the system architecture. First of all, the first part comes of making the data set, where we are using PDF processing, and we are using RAG and using FAISS vector database to create our own data set. It is a very authentic data set. Next, everything from the data set goes to the model. The model we are using is Llama 3 8 billion parameters instruct model, and we are providing it with our own data. This part is the actual fine-tuning method, and there are many parameters related to PEFT and LoRa parameters. We plan to hyperparameter fine-tuning, and later push the fine-tuned model to Hugging Face, where everyone can use it. And also we have already made the model available to use using Hugging Face spaces. Now next comes the most important part of our project, the research part, where we plan to publish a research paper based on the research we have done and increase the accuracy compared to all other solutions provided in the market. So for considering our accuracy and performance metrics, we are using 2 very important performance metrics which are very relevant when we speak about LLMs. First is BLEU, which evaluates machine generated text by measuring matching n-grams with the reference, focusing on precision. And second is ROGL, which measures the longest common subsequence between texts, focusing more on recall and sequence level similarity. For the base model, which we have used directly from Unsloth, the blue score is 12.17% and Roche L is 13.6%. But when we fine tune the model with all the default parameters of LoRa, we get the blue score to 20.16% and Roche L score of 18.21%. But later, after hyperparameter tuning, we get blue score as 21% and Roche L score as 19%, which is a huge W for us. So with this, I would like to conclude our presentation of our project. The project aims to develop a domain-specific chatbot trained on Indian property law using Unsloth. And as you can see, we have already achieved a lot in the process which we were planning to go about. Furthermore, there are many things which we can do with the project. For example, implementing an MCP server for the project to make it more robust and implementing RAG services to make it more live. Thanks for your patience. Have a great day.